All right, welcome back to section 15.1. Example 3, Neil, a third grader, asked 10 of his classmates whether they prefer to wear shoes with laces or without laces. Most of the classmates Neil asked prefer to wear shoes without laces. Discuss whether it could be reasonable to assume that most of Neil's class or most of the students at the school would also prefer to wear shoes without laces. So there's a couple things going on here. First, Neil asked 10 of his classmates. Well, this will not produce a random sample if we just ask 10 people without properly doing a random sample. So this will not produce a random sample for the school, right? Neil's in third grade. So if he only asks 10 of his classmates, that's not going to be representative of the school. Now, maybe for a class, it might be representative for his class, but we don't know how he determined those 10 classmates, right? So it's hard to know if it's representative of his class, but it might be representative of his class. Because 10 out of, say, 30 or 10 out of 20 might actually be representative of the class. But there's no way that this is representative of the overall population of the school, because his class might be different than the rest of the school. Maybe because he's younger, they're less likely to wear laces. So this is not representative of the school. An announcer of a TV program invited viewers to vote in an internet poll indicating whether or not they are better off economically this year than last year. Most of the people who participated in this poll indicated they are worse off this year than last year. Based on this information, can we conclude that most people are worse off this year than last year? All right, so inviting viewers to participate, this right here, this is called self-selection, right? And the thing about self-selection is it's not great because only those people with a strong interest in a poll will vote. So if you kind of think about social media, the polls that go on in different people's, you're not responding to any one that you don't actually have an interest in. Maybe you have an interest in the person, or maybe you have an interest in the topic. So this poll will only elicit answers from people who are really have a strong interest, and also only people that have access to internet. So that's not really representative of the whole population. Okay, so self-selection is a knock against it because of access to internet and self-selection, strong interest only. So we're not getting the people that maybe don't really care. And those people are still part of the population. So we're also only asking the people that watch the show. That's a particular kind of person also, and that might skew the data. And then finally, the question of what the heck does worse off mean? I might interpret that differently than you might interpret that. So are all the people polling interpreting this the same way? So this is not enough to conclude that most people are worse off. So a group studying violence wants to determine the attitudes toward violence of all fifth graders in a county, and they plan to conduct a survey, but they don't have time or resources to survey every fifth grader. So the group can afford to survey 120. For each of the methods A through C, discuss the advantages and disadvantages of that method, and then based on that, which of the three would be best to determine for all in the county. All right, so A, have each elementary school principal in the county select 20 fifth graders. Okay, so an issue here the principal might have bias about who they're asking. They might only ask who they deem as good or who's finished early, so it's not impacting their school. Have each fifth grader teacher in the county select. So that's going to be the same disadvantages of the above, because a teacher might only select who they decide are good or who are finished early, so it won't interrupt their schooling. Obtain a list of all fifth graders in the county in 120 random numbers, and then use the list of random numbers to select. So this here is a random sample, and this is going to be our best bet. A website posts evaluations on professors. It posts 3 most positive and 3 most negative. Discuss the usefulness of this feedback for a reader wanting to know about the professor. All right, let's go through this here. The reader can accurately assess the professor based on the posted evaluations. Well, if I see 3 good things and 3 bad things, I might not really be able to accurately assess. I'll say maybe or no here. And this is how I like to do multiple choices, go through them all. The reader cannot accurately assess the professor without reading all of the evaluations. I mean, maybe one really bad one tells me everything, or one really good one. This is going to be a maybe. I'm not really sure. The reader cannot accurately assess the professor because the method of choosing the sample is unclear. Well, that's true. I don't know how they determined those 3 best and 3 negative of all the samples, right? Like, I don't know out of how many positives or how many negatives. The reader cannot accurately assess the professor because the evaluations posted are not necessarily representative of all evaluations. Well, that's also true because, again, I don't know how many positive or negative. So go ahead and give these a try. Press play when you're ready to see the solution. And there we go. So predicting the characteristics of a full population. So if we have a random sample, then the characteristics of the sample are likely to be very close to the characteristics of the full population if the sample is large enough. So in other words, sufficiently large random samples are likely to be representative of the full population. If we kind of go back to that cornfield, if I only pick 3 out of 1 million corn, it's not going to be enough. But let's say I have maybe 600,000, right? Corn of the million. That is 60%. That might be enough. So for example, if 54% of a large enough random sample of voters said they were likely to vote for candidate X, then it is likely that close to 50% of the full population will also vote for candidate X. Go ahead and complete this exploration. I know that there's a lot of pieces to this exploration, but I encourage you to take the time, maybe get something similar to beads, because it's really going to help you make sense. The math that's coming up can be a little tricky. So starting with a hands-on activity is going to help you here. And then press play when we're ready to move on. All right, so let's go through this and then we'll do some examples. All right, suppose that a factory had... At a factory, 450 transistors have been produced. A random sample of 75 is selected, and of the 75, 3 are found to be defective. How many defectives should we expect to find among the full population? All right, we're going to solve this in a couple different ways here. So because the sample of 75 was chosen randomly, it's likely to be representative. So there's a number of ways we can determine approximately how many are to be defective. All right, so let's start with a proportion. If the sample is perfectly representative of the full batch, so we've got 3, these were defective, right? 3 were defective of the total sample, and this is our sample, and this is the full population. This fraction here is our sample, and this is our full population. So we can say, all right, I know that there's 3 out of 75 in the sample, which is equal to X over 450. And so we can do what we've done before, which is we can solve this either going across or within. So maybe you know that to get from 3 to 75, we would multiply, but remember, we can't multiply, we want to go this way. So 75 is going to be divided by 25. So we're going to divide this by 25. So we would see, okay, then there's going to be X equals 18. We could do that another way if you remember from our previous section. Maybe you know how to get from 450 to 75 times by 6. So we would just times that by 6. 3 times 6 is 18. All right, let's think of it another way. We could also think of it in batches. So if each batch is like the first one, here's our first batch. Okay, so in our first batch of 75, we would get 3 defective. So if we grabbed another batch of 75, so now our total is 150, we would get 6 defective, right? 2 batches. And then if we did it again, we would have 75 plus 75 plus 75, and 3 plus 3 plus 3 would get 9. And we could keep going until we get to 450, and we would get, and see that there are 6 batches of that sample, and so we would get 18. Okay, there's actually another way to think about it. is to imagine distributing them into bins. So then 3 of those bins, so if we have 75 transistors and they're all going into a bin, so 3 of those bins are defective. Now imagine distributing the full population of 450 among those 75 bins so that the defective transistors only go into those 3 bins. So if the sample is representative, then we should be able to distribute the transistors equally among the bins. So because 450, so we got 450 in our hand, we're going to divide it into 75 bins. We're going to get 6. So 6 bins, each bin will have 6 transistors in it. So 3 bins for defective transistors will be 3 times 6, which is 18. We can also reason about the bins in another way. Because 3 out of 75 are for defective transistors distributed equally among the bins, then 3 out of 75 of all the transistors are defective. And so we could say 3 out of 75 times 450. And again, we'll get 18. So we're going to pause there before we do some of these longer examples.